What if I told you there's a scientist that never sleeps, never even needs a coffee break, and can run like 1,000 experiments while you're just having dinner? Well, it's not science fiction anymore. Today, we're going to dive into a system that's making this a reality. It's called the AI Scientist V2.
Okay, so look at this quote. This manuscript was autonomously generated using the AI Scientist. Now, this isn't some line from a sci-fi movie. This is a real, actual disclosure from a scientific paper. And get this, it's a paper that's already been submitted, peer-reviewed by human experts, and yep, accepted for publication.
Yeah, just let that sink in for a second. What the AI Scientist V2 did here is a massive milestone. It generated a complete scientific paper all on its own. I mean, from the very first spark of an idea all the way to the final manuscript. And it wasn't just some junk paper. It was good enough to pass the tough scrutiny of human experts.
All right, so let's get into it. What exactly is this system? It's from a company called Sakana AI, and it's built to automate the whole scientific process from start to finish. But, to really get what makes this version so special, we've got to look at how it grew from its first version.
So the leap from version 1 to version 2, it's a huge deal. The first AI Scientist was kind of like a super skilled assistant, right? It was fantastic at following a very specific template that a human gave it. But V2 is totally different. It's an explorer. It doesn't need a map or a template. Now, that does mean its success rate for any one specific task might be a bit lower, but that's the point. It's designed to find things we haven't even thought to look for yet.
And we're not just talking about an AI that helps out with one piece of the puzzle, like crunching the numbers or something. No, this system is designed to automate the entire cycle of scientific discovery, the whole shebang.
And when I say the entire cycle, I mean it. We're talking about coming up with a totally new hypothesis, running the experiments, analyzing all the data, and then writing everything up into a paper that's ready to be published. It's a complete end-to-end system.
Okay, so the big question is, how on earth does it actually pull this off? Let's pop the hood and take a look at the mechanics of how this thing really thinks and works its way through a research problem.
Well, this whole, super complex process, it really boils down to two main stages. Step 1, it comes up with the research ideas. Step 2, it runs the experiments and writes the paper. Sounds simple, right? But trust me, the details are where it gets really fascinating.
So that first stage is called the ideation phase. You basically just give the AI a broad topic and off it goes, brainstorming. But here's the cool part. It's not just randomly guessing. It's using tools like the Semantic Scholar API, which is basically a direct line to a gigantic database of scientific papers. It's doing a literature review, making sure its ideas are actually new and not just rehashing something that's already been done.
All right, so once it's locked onto a genuinely new idea, it moves into the experimentation phase. This is where the real work begins, It uses this really sophisticated method called agentic tree search to actually do the research and see if its hypothesis holds water.
So what in the world is agentic tree search? Well, think of it like this. Imagine you have a whole team of tiny AI agents. You send each one down a different path to try and test your idea. Some of them explore and hit a dead end. Others find something really promising. And all of them are constantly reporting back to the main system. The system then acts like a manager, pulling resources from the dead ends and pouring them into the paths that look the most promising. It's basically managing a whole research department full of AIs.
Okay, I know what you're probably thinking. This all sounds incredibly complicated and, super expensive, right? Well, let's switch gears a bit from how it works to what it actually takes. Like, what would you need to run one of these experiments yourself? And this is where it gets pretty wild. A single complete run, I'm talking from idea to finished paper, using a really powerful model like Claude 3.5 Sonnet, it costs about $20. $20. Now, it's not free, obviously, but that is remarkably accessible. This kind of affordability could totally change the game, opening up high-level research for smaller labs or even just curious individuals in a way we've never seen before.
Now, of course, it's not quite as simple as just downloading an app on your phone. You do need a specific setup. You're going to need a Linux machine with some beefy NVIDIA GPUs, the PyTorch framework, and API keys for a big language model from someone like OpenAI or Google. But the most important, absolutely crucial requirement, a secure, controlled sandbox environment.
And there's a very, very good reason why that sandbox is so important. The creators themselves put this pretty serious warning right there in the documentation. You have to understand, this isn't just an LLM writing text. It's an LLM writing code and then executing that code.
So what does that actually mean? It means you're giving the AI a ton of autonomy. It could, in theory, go out and access the web, install some dangerous packages, or just start running processes you have no control over. That's why running it in a totally locked down environment, like a Docker container, isn't just a friendly suggestion. It is an absolute necessity for safety.
So let's take a step back and zoom out for a second. What does all this really mean for the future of science, for the future of discovery? Because this isn't just a small incremental improvement.
What we're looking at here is a fundamental shift in how we relate to AI. We are moving past the era where AI was just a helpful tool, something that crunches numbers for us or helps format a paper. We are walking into an age where AI can be a genuine research collaborator, an independent agent of discovery.
And that leaves us with a pretty massive question, right? If an AI can be a scientist, if it can come up with its own ideas and run its own research, what does that do to the speed of innovation? I mean, what kind of problems could we solve if we had tireless, autonomous researchers working on them 24/7? It really makes you think, what's next?